apparent wave period. So say we have a vessel over here, and the vessel is moving in this direction. Say we have here a vector of v as the vessel speed. Now let's have a wave, more or less a wavefront here and here as well, and this is a wave crest, and that's not a wave crest. So we can see that the wave is moving in this direction. So this will be the length of the wave, sometimes called lambda. It's the same as the speed of the wave, cv times the period of the wave. Okay. Interesting to see is that the wave has also a speed in the direction of the vessel. So we say this point is point A, and here we have a point B. What we do here is we make another line perpendicular to the wave direction, so here, and that's the point C. And the angle over here, that will be something like alpha, and alpha is the angle between the ship direction and the waves coming in. So this blue vector over here is v wave in the direction of AB. Okay, so now we could have a look at the rectangular triangle. So triangle ABC looks something like this, with a straight angle over there. So that would be A, B, and C, and this is the angle alpha. So in the picture we see that here we have the CV, the speed of the wave. So the wave is wave is moving in this direction, and here we have the speed of the wave in the direction AB. So we could say the cosine of alpha is something like speed of the wave divided by the speed of the wave in the direction AB. Well, we are particularly interested in the speed of the wave in the direction of AB, which would be something like speed of the wave divided by the cosine of alpha. Okay. Say that the apparent wave speed here in the direction of AB, we call that one v wave AB with an accent, is something like the speed of the vessel in this direction added by speed of the wave in direction AB. But we know the last one because this is Vs added by Cw divided by the cosine of alpha. We also know that the apparent wave speed AB is something like AB divided by T, the period of the wave, accent. So where's that one? Well, maybe give it another color here. So this in the direction of AB, so same direction as the course, this is your T accent of the wave period in the direction of AB. So this would be your apparent wave period. Okay. Well, let's combine these two equations here. So we combine those two, and we could say that AB divided by the apparent wave period equals V as on-ship speed added by wave speed defined by cosine alpha. Okay, we make another triangle. because I would like to say something about the AB. Put it over here. Still got some space here. Make the same triangle. We have A, B, and C, straight angle. So this is also the length of the wave, given in blue over here. So make that blue as well. So this is our L, length of the wave. Sometimes called lambda as well. What do we know as well? We have here the angle alpha. So we know that the cosine of alpha would be length of the wave divided by AB. So now we could say, oh, in that case, AB is something like length of the wave divided by cosine alpha. And we can put that one over there. So we get something like length of the wave divided by cosine alpha times the apparent wave period equals, well, now we do a small trick here. See, we have a cosine here, we have a cosine there. So we say Vs times cosine alpha divided by cosine alpha. We do nothing wrong, except when cosine alpha would be 0, but we come to that later. Added by the wave speed divided by cosine alpha. Okay, and we say cosine alpha is not 0. That would be the case if alpha is 90 degrees. Well, then we're not so much interested in the apparent wave period. Well, let's work this out. I go to the left over here. So you could say that the length of the wave divided by the apparent wave period is something like own shift speed times cosine alpha added by wave speed divided by cosine alpha. Something like this. Yes, we're almost there. We have to do one more thing, and that's find out what the apparent wave period would be. So I do a trick over here. We say the apparent wave period equals 1 times the length of the wave divided by, and then we have the thing over here. I'm not sure this is right. I put here the cosine alpha, but we said that's not good. So that would be a 1, because here we have a cosine here, a cosine there, and a cosine there. So we skip the cosine because it's in every denominator. So we only have the cosine here, which would be that one. Okay, so I have speed of the vessel times the cosine alpha added by the wave speed. Well, this might not look familiar to you. You could also say, well, I would like to express the length of the wave in something like, and we discussed this before, c wave times t wave. So, but most of the times we express it like this, and we use the length of the wave. So here you got a formula for the apparent wave period. Thanks for watching.